Okay, the second half of the final exam. So we're starting with question 5. It's been a while since we've done these problems, so you may have forgotten. So this is the circle. It's not in standard form. You got to write it in standard form. So the first step of that is to start rearranging everything. Put the axes together. You know, I'm going to need to put something here in a minute, but I'm not going to do that yet. Put the y's together. And then the number, move it to the other side. There's always a number by itself. So that's step 1. You're getting it ready to complete the square on each of these. So put the x's together, put the y's together, move the number. I want to see every one of these steps. You do not skip these steps now. The next step is where I'm going to have to create my little space. I'm going to put a number there, so I leave a gap. And the same thing on this side. I'm going to put a number there, so I leave a gap. I screwed up. I don't have enough room. I'm not going to fit it. So I take half of this number, which is -4. I square it. I take half of this number, which is +5. This is important. Make sure you have the sign right. Square it. -4 squared. And, you know, actually, I'm going to do it underneath so I can fit it correctly. So half of this squared, -4, right? Squared is 16. So I'm going to add 16. Half of the 10 is +5. I'm going to square that. 5 times 5 is 25. So I'm going to add that. Now, on the other side, you have to put these numbers you just added. This number wasn't there, and this number wasn't there. If you want to keep your equation balanced, you got to make sure you add to both sides. Now, this actually comes out pretty nice. Now, you got to factor this. It's going to be x squared. The number you put here is right there. It's the number you got when you took half of -8, which is -4. Again, make sure you sign it right. You got to put a plus here. Put parentheses, put squared, put the y. What number goes there? Half of +10, which is +5. Again, you got to make sure your signs are right. Now equals. Now just add all this up. I believe this is 41. Take away 40. Wow, that was nice. This is your standard form. Something squared with an x plus, don't forget this plus. People forget this plus. It's wrong. You're going to lose points for it. Something squared with a y, right? Those numbers. Half of -8 is -4. Half of +10 is +5. Just make sure you have those numbers correct. And then I got a 1 on that side. So now remember how to find the center. Center is easy. It's the numbers that are in there, but you got to switch them. So switch that to +4. Switch that to -5. And then the radius. Now here's where people freak out. I gave you a nice one. Like, I don't know the square root of 1. What times itself is 1? So the radius r is 1. Boy, that's easy. That's going to be a pain in the ass to draw, though. Up 1, down 1, left 1, right 1. So I'm going to plot the center, and then I'm going to use that radius to make 4 more points, and then I'm going to connect them in a circle. Right? This is what you got to do, so I'm going to do it. We know it's a pain in the neck. So I tried my best to make an accurate grid here. So I have to go 4 to the right. 1, 2, 3, 4, and then down 5. 1, 2, 3, 4, 5. So right about here. I mean, it's not perfect. It's not going to be perfect. All right, I tried my best. So there's my center. Now, starting with my center, it's giving me a hard time here. I'm going to go up 1, down 1, left 1, right 1. So I'm going to go up 1 to here. Try to keep it right above. Then I'm going to go down 1. So it's about here. The dot's not perfectly lined up here. Down 1. Make my dot bigger so it's right underneath. Now I'm going to go left 1. All right there. And then I'm going to go to the right 1. And then, you know, just make the arcs. My circle is not going to be good. Boy, that arc was so crooked. I tried. It's circular. Make my dots bigger. Now, the problem is that I didn't label my dots, and I have to. So I have to put my points. This is very important. Some of you on the second exam, when we did the circles, you didn't put the friggin' points down. you got to label them. So remember, the center was 4, -5. And I went up and then I went down. So I stayed at 4. Right? And then I went up 1, which would be -4. And then I went down 1, which would be -6. Now, going left and right, this is when the x changes. The y value doesn't change here, right? Because you're going left and right. So the y value stays at -5. And then I was 4, and I went that way. So that dot is at 3. And then, again, I was at 4, so I went this way. So you add 1, and you get a 5. And, you could just use the grid to make the other dots. So, I don't know, my marker's being funny here. I'm trying to make my dots darker. So, all right. I mean, the circle problem is worth 6 points. You got a big chunk of points for completing the square correctly, writing it in the proper standard form, telling me the center and radius. That's probably about half the points. And then, you got to draw. Don't worry about your circle being perfect. I mean, mine looks okay. I mean, it's circular. But the important part is that I have all the points. If those points are missing, you're going to lose at least 2 or 3 points out of the 6. So just be really careful and make sure you label your points correctly. All right. So it's not a super hard problem, and the rest actually get easier. So we already did the hardest one. Okay, 6a. Now, this question says solve by factoring. I didn't write that down. You can certainly solve it with the square root, and it's going to be marked wrong. If it says solve by factoring, that is the technique, then you have to factor this. Now, this was the difference of perfect squares. A lot of people forget. Something times itself to make this, right? You need something times itself to make 64. So this is why you have to pick 8x and 8x. And then you need something times itself to make 81. And again, it has to be 9 and 9. One guy gets the plus, one guy gets the minus. You can put them any way you want. You want to put minus plus, knock yourself out. It doesn't matter. As long as they're different. That's what makes the middle term cancel out. You don't have a middle term, right? You have just a binomial, 2 terms. So factor. And then if the product of 2 things is equal to 0, one of them must be equal to 0. Now, I understand at this level, you could all do this in your mind and tell me the answer, but it is important, right? You're doing this question for 3 points. This is a really easy question. You have to show me the work. I need to see the step. I understand it's ridiculous. Right? You add the 9. You get 8x equals positive 9, divide by 8. Sorry. And you get 9 over 8. And then if you want to write it as a single thing, if you want to be all fancy and sophisticated, you could put plus minus 9 over 8. But this is fine, right? This is fine. This is what you do. You factor it. You set each factor equal to 0, and then you solve it. Show me the steps, please. You're going to lose a point if you just jump from here. I see people jump from here to here. They don't even set the damn things equal to 0. I mean, you can't skip a lot if you want to get the full credit. So make sure the work is there and make sure it's correct. Okay, solved by square root property. So this problem can get a little nasty. Remember, the goal is to get the squared thing alone and then take the square root of both sides. So you have to get rid of this positive 11 by subtracting 11 to the other side. Cross that out. It's not there anymore. That's why I subtract the 11, so it goes away. So now on the other side, remember, you lose 21, you lose 11, you lose 32. So you have negative 32. Now you're ready. I want this alone, so I have to get rid of the square. The way you do that is to take the square root of both sides. The square root and the square cross each other out, and you just get 2x plus 6. On the other side is very important, plus and minus square root negative 32. Make sure it's there. Don't let it magically appear at the end of the question. It goes right there. All right, now I have a lot of steps to do to break that down. I'm not going to mess with my 2x plus 6 yet. Now you're going to be very careful with 32. First, I'm going to take out the negative. Right? Remember, the negative inside comes out as I. Now I want to break 32 down with 2 numbers. So your instinct, right, might be to break it down with 4. The problem is there is a larger perfect square. that divides into 32. You might not spot it, and this is what you have the damn calculator for. You should have a list of the perfect squares, right? 1, 4, 9, 16, 25. Start trying to divide 32 by them. You could try dividing 32 by 25, and it ain't gonna work. It's not divisible by 25. But if you do 32 divided by 16, it's 2. So the pair, the correct pair, is 16 and 2. 16 is a perfect square. It comes out of the radical, out of the jail. Free him. And remember, don't hop over here. This is going to hook up with the I. So keep the plus minus. You get 4I radical 2. Notice, all of these radical people are on the right of this plus minus. You do not cross over to the left of this plus minus. You keep them there. Now, I have to take away this 6. I'm solving for x. I need x alone. So I'm going to subtract 6 from both sides. Now, remember where it goes. It goes to the left of that plus minus. Don't write this backwards. I have a problem with that. If people put this minus 6 over here, don't do that. I'm going to mark it wrong. So it's not the correct form. This is the correct form, right? This is what the quadratic formula looks like when you do it, right? It's negative b plus or minus b squared. It's not radical b squared minus b. The negative b goes in front, so you got to make sure it's there. Now I have to divide everything by 2. Right? You have to cross that 2 out. Now, fortunately for me, this number and this number are divisible by 2, but this is a trap. He's in jail. He's not in jail. No matter how nicely you ask him to go in there and divide that 2, he ain't going in that jail. So you got to divide the numbers outside by 2. Just cut them in half. So you get negative 3. Plus minus stays where it was. Don't change that. 4i gets cut in half to 2i. And what does the radical 2 do? Nothing. It goes along for the ride. Just leave it alone. I'm not putting a line for fraction. I was putting a line for my answer. Let me not do that. I was just underlining my answer. I don't want you to think that the division line is still there. All right, so get the squared thing alone. Square root both sides. Don't forget the plus minus. Take the negative out as an I. Break the number down. Pull the guy out of jail. Get the number over. Divide everybody if they divide. You know, if there had been a 4 on the bottom, you would be able to just cut the numbers in half. You wouldn't be able to divide. You know, if this, I'm saying this because I know the question on your final exam. The question in your final is going to have numbers that don't quite go in. Like you might be tempted to cross these 4s out, which is a trap. Don't fall for it. If it was 6, 4, and 4, the only thing you could do is cut this in half and make this 3, 2, and 2. And you'd be left with a 2 underneath it. So if it doesn't divide evenly, this one was nice, it divided evenly. But if it doesn't divide evenly, don't just cross it out with one of the numbers. Make sure you reduce them all, figure out what they all divide by, and then divide them all by that. All right, so that's a little secret hint for the real thing. All right, 7a, combining radicals. Oh, this one is such a trap. You see a radical 72, you see a radical 8. And your first instinct might be, oh, 72, 9 and 8. Break it down with 9 and 8, and then they have the same radical inside, but that's the mistake. That's the trap. Radical 8 breaks down with 4 and 2. And as soon as you see this 2, right, this is an add and subtract radical problem. You cannot add or subtract radicals unless the radical part has the same number. So as soon as you see this radical 2, you know for a fact that this radical must be written with a 2. It has to be. So you always, my advice to you, take the smaller number first. In this case, it's 8. And break that one down and see what number you get left over that's going to be in the jail, right? 4 is coming out of jail. The 2 is stuck inside. So that tells you how to split 72 up. It is incorrect to split 72 up with 9 and 8. But I'll just keep going. As soon as I see you pick the wrong pair, it's going to cost you. All right? I'm not going to mark that correct. It's 36, right? How do you know? Once again, calculator. 72 divided by 2 on the calculator, you get 36. Now, I split them up properly. take the ones that come out of jail and take them out of jail. Remember, if there's a number outside waiting, every step has to be shown here, right? 36 gets freed. What does it come out as? 6, because 6 times 6 is 36. Don't do anything cute. Don't do anything different. You do what I taught you. The 9 is waiting. What's it waiting for? It's waiting for the 4 to come out. 4 comes out as 2, because the square root of 4 is 2. So you take them out of jail. So first you split them up. Then you take them out of jail. Then you combine, right? Here you get 2 times 6, which is 12. 12 what? 12 radical 2's. Minus 9 times 2 is 18. So you have 18 radical 2's. Now it's done. They have the same radical part. You have 12 of this thing. You're going to lose 18 of it. So 12 minus 18 is negative 6. But you can't have a negative. You have a negative out in front. Who gives a damn? All right? Every step I did. Any of these steps are skipped. A lot of people like to skip from here down to here. They don't show the coming out of jail and then that they hook up. It's a big mistake. It's a problem. You know, this guy's big day. He's getting out of jail. It's just, you got to show it. Show that he gets out of the jail. He's free. Then he's going to hook up with his buddy. All right, so you have to show every step that I did the same way that I did. You do any weird, crazy crap. I see people take 36 and they write it as 6 squared. Well, they do radical 6, radical 6. This is all nonsense. You don't do this. It's a perfect square. Out of jail. Boom. One step. Radical 36. Boom. 6. Nothing cute. Nothing fancy. I see this stupidity. It's marked wrong. Okay. This is nonsense. We don't do this. This is not how you do this. All right. So don't do anything that I didn't show you. All right. So the multiply radical problem. No, it makes sense that this is with the combined radicals. They're a similar topic, right? You know, the solving by factoring and solving by square root together is a question. Combining radicals and multiplying radicals together is a question. So this isn't that hard, but you have to be very careful to keep track of it. Remember how you multiply radicals. You multiply the numbers on the outside and then multiply the numbers on the inside. So again, first, you know, this is what you're going to do, right? First, outer, inner, last, right? So first I'm going to multiply these together. I'm going to do 3 times 2, which is 6. Radical 3 and radical 3 is radical 9. You know, I'm using my fingers to help me. 3 times negative 3 outside. It's negative 9. And then radical 3 and radical 6 make radical 18. Right? Multiplying them. Done. Now, I'm going to do, whoops. This is what happens. I don't have 3 arms. I'm going to multiply these together, trying to cover that. Right? Inner, outer. That's the whole FOIL. There's no number there. There's a 1 there. On the outside, you get 1 times 2. Now, remember, you know that I like to go underneath. So 2, radical 6, radical 3 is radical 18. Because, you know, then you line them up. The like terms are, you know, together. Again, if you want to put a 1 there, put a 1 there. 1 times negative 3 is negative 3. And then radical 6 and radical 6 is radical 36. Boom. There we go. So now start taking everybody out of jail. I get 6 times 3. I'm going to combine these together. I get negative 3 times 6. Now, those are both 18, so they're going to cross out. Here's the thing I got to pause about, because it was annoying me. I remember on the exam, I think it was test 2. Maybe this was test 1. If you break the radical 18 down here, I know for a fact that the solvers do this. And I also know for a fact that human beings don't do this. I've never seen a human being in a classroom break the radicals down before they combine. It doesn't make any sense. You have a like term here, right? Negative 9 plus 2 is negative 7, radical 18. Why would you not do this? Combine them. Then at the end, you'll notice, oh, 18 breaks down. So look, you have 3 times 6 here, which is 18. This radical 18, I'm going to break down with radical 9 and radical 2, right? 3 times 6 is 18. Look, this one and this one cross out. They're not there anymore, right? Goodbye. So you only have this. These wipe out. I mean, if you want to cross them out here, you can cross them out here. It's the same thing. I will not break this 18 down here. It is stupid to do that. You combine them first, Then you break it down. So then you take the radical 9 out of jail is 3. Hook it up with the -7, and you get -21 radical 2. So this product, this whole big multiplication I did, that's all you got. One little dude left over. All right, so again, proper form, proper technique, proper steps. Not combining these together first is an incorrect step. It's just not right mathematically. You combine like terms before you break the radical down. If I see you break the radical down up there, I'm telling you that I'm going to deduct a point. That's the whole purpose of this video, is to tell you what to do and what not to do. Don't break them down until you combine them together. Okay? All right, the last question of the group of 4. Like I said, this half of the final is significantly easier than the first half that has a trig. So, vertex. There's only one way to do it. Well, there's only one way we do it, and that is with a formula. Now, the formula doesn't tell us the vertex. The formula tells us the x coordinate of the vertex. So make sure you make this clear and put x equal. So what's b and a? Well, a is the number in front of the x squared. It's -2. B is the number in front of the x. It's -12, right? A, B, C. We don't need C here. So negative b, but the problem is b is -12. So to be very careful with your signs. I see people massacre this question because they butcher their signs. And then a is -2. Whatever you do, under no circumstances are you just switch those signs. Cannot do this. It's a completely different thing. This is not an equal 0 here. There was a y there. So you can't just switch these signs and make them plus. You might be tempted to do that, but you can't do that. It's not going to work, all right? So negative b is -12, so that's going to switch. When you do the negative of a negative, it becomes positive. On the bottom, you get a -4. 12 divided by 4 is 3, and the signs are different, so it's -3. That's the x part of my vertex. Now I'm going to plug that in to get the y part. So wherever you see x, you put -3. And again, as long as you're careful with the signs, you don't have to be too careful. Use it. You have it. You didn't have this when you took that test with this problem, but now you do. So you may as well use it, right? -3. Now be very careful. Cannot hop the fence with the power on. If you do 2 times 3 and make a 6 there, just kill the whole thing. Do this power. -3 squared is +9, right? -3 times -3. -12 times -3 is +36. You're taking away 11. This is 18. And it's negative because negative times positive is negative. So let's see. 36 minus 18 is 18. 18 take away 11 is 7. No one's here to answer me, so I'm assuming I did this right. There's my vertex. I got my x with the formula. I plugged it back in to get the y value, right? Don't forget to get the y value, as a lot of people do the x perfect and then they just stop. The coordinate has an x and a y, so make sure you plug back in. There's only one more question, which is the one that everyone hates for some reason. Okay, question 8b. Now, I'm going to be really honest with you. It's the easiest question on the whole final, and yet some people are freaked out by this. It's very simple. All the numbers are perfect squares. They just happen to have negatives there, right? This is a complex number problem. So you're going to have a bunch of i's in it. One at a time, very careful. Take them all out. Just follow what I do, and you will get easy 3 points. This question is a gift. Now be careful. Here's a plus. Here's a times. Here's a plus. Remember, like here's a question I give my remedial students. 5 plus 3 times 2. And they will go for this every time. 5 plus 3 is 8. And then 8 times 2. You're violating the order of operations. Addition and subtraction are right. This whole stupid PEMDAS thing. Multiplying and dividing always come before the adding and subtracting. You cannot add until you have multiplying. So that's the reason you have to be very careful here. This problem is set up this way. Square root of 25 is 5. What about the negative? That comes out as I. Plus. Square root of 16 is 4, and the negative makes it 4i. Times. Square root of 64 is 8, and you have a negative there, so it's 8i. All of these are going to have an I. plus square root of 81 is 9, and it has an I with it. Now, you see these two? They're being multiplied. You cannot do 5 plus 4. You might want to do that, but you can't do that. You violate the order of operations. Adding and subtracting go last. So multiply these together. 4 times 8 is 32. But what about I? I times I? Uh-oh. I squared. Oh, we've seen that before. That's the one that I told you to memorize. But you don't have to memorize a damn thing in this class because you got the notes. I squared is -1. Now, what about the 5i? It's waiting. Well, you can add these together. No, you can't. I and I squared don't add together. Oh, you know what adds together? These add together. Ooh, look, there's 5 idiots and then there's 9 idiots. That's 14 idiots. Yay, or ice cubes. I don't know what the hell starts with I. So you have 5i and 9i. You can add them. You can add them together. So 5i and 9i make 14. I, not I squared, right? If you have an ice cube and an ice cube, you know, you don't have an ice cube squared, right? Now here though, where the I squared is, you replace it with a -1. Now this is positive, right? +5, +9 make +14, right? 5i, 9i, 14i. This I squared gets replaced with a -1, and then 32 times -1. Ooh, look, it's in complex form. A plus bi, right? A plus bi. There it is. This is a simple question. Don't let it get in your mind. It's so easy. Everybody comes out of the radical, and they all come out with an I. Why? Because there's a negative, a negative, a negative, a negative. They're all perfect squares. They all come out, and they all come out with an I. This one and this one are being added. So you have to wait first to multiply those two together. You get the I squared. I squared does not add with I. So you take the two i's and put them together. You take the I squared, you replace it with -1, and it's over. Now you have A plus BI, right? That's a complex number. That was the standard form. Every complex number looks like this. Real part, imaginary part. Done. For 3 points, this question is an absolute gift. All right? There's nothing to do. Just take the things out of the radicals, and the i's you multiply and get I squared. I squared gets replaced with -1. The other ones are just numbers, right? 5i, imaginary number. 9i, imaginary number. Combine those and you get an imaginary number. All right, this is not a hard question. Don't get this wrong, please. It's 3 points. It's so easy. It's a 3-point gift. You should not get this wrong. All right, so that's the whole second half of the final. 5 through 8. It's not a difficult test. You have to go back and review the stuff, you know, that we did from test 1 and 2, but none of it's that hard, and you have the whole weekend to prepare for it anyway. So I did them all. Watch the video. Make sure you just copy what I do when you do the questions. All right, and as always, good luck.